Shut up and sit down.
Hi everyone, welcome back to the next live coding session with me. I'm Kitecraft, and we are working on HardSense, specifically HardSenseESP. That's what you see is going on in the top corner there. That's an ESP32 microcontroller with Wi-Fi, Bluetooth, a bunch of pins, a file system, dual core 250 megahertz CPUs. There's a whole bunch going on, and what you can see is just there's simply right there a small 2.8 inch little display pumping out some information. So that's HardSense. For the returning viewers, welcome back and nice to see you. We left off at the last session when I was we were looking at adding over-the-air updates capabilities. I'd already gone through and we'd reformatted the partition size to make sure that it was going to fit my application, and I changed my font sizes to fit a tiny SPIFFS. So we've got the partition that's going to fit everything. I've done some tests with the over-the-air updates and the default basic OTA scripts, this thing right here, and that all worked fine, so we were looking good. So the next thing I was working on was now adding in a place on the screen here, or somewhere on the firmware, where we can actually have an OTA capabilities. Let's back up and look. So what we're looking at here for the ESP32 program is we have the microcontroller sitting over here. There it is. And it's connected to my home network through the Wi-Fi, and it's used over the Wi-Fi. It is in fact then connected to the HardSense program running on my computer. Oops. So this is the HardSense Windows program. This is actually loading up all of the available sensors from the computer, things like hard drives, motherboard, fan controllers, GPU speeds and temperatures, all of that stuff. Sets up a TCP server and is ready to actually start streaming that data. So the microcontroller that's living right here, this is actually connecting to my network and then connects to the HardSense server, and each one of these screens that we see being displayed down here is streaming back live sensor data from my computer. So on this particular screen we can see it's displaying CPU information. The GPU is my video card information. We have the hard drives, the current date and time, network up and down speeds. But one of the really best features about this is a touch screen. So I can just simply touch on the GPU panel and I will come to my specific game screen where I'm streaming specific data about my video card, information that I want to see when I'm playing a video game. We have a 90-second graph for the GPU's temperature and fan speeds. We have a live updating core. The RAM panel up here, this is for the video card RAM. My video card here has, I think, 12 gigabytes of RAM. We have our repeating net panel, FPS counter. This is a built-in frame rate counter that I've added to HardSense. We can go back to the home by touching on the bottom, our CPU screen. So again, we can actually break down all of the sensor information coming from my computer, breaks this down into 6 processors on my CPU. Task Manager will show you 12 threads, but it's actually 6 physical cores. So what we're seeing on this screen is the actual information for the 6 physical cores, including their current speeds, temperatures, and usages. Well, it's definitely warming up in here. Anyway, so last I left you guys is I was looking at adding over-the-air firmware updates. As you can see, it is still plugged in by a USB cable. Now, it's not getting the data off of the USB cable. It's just simply set up so that I can do the firmware updates. As we're programming this with VS Code, that's my editor that I've been using, writing all of the code, we do the updates through that wire. I want to get rid of that wire because when we put this into a box, pardon me, The final project for HardSense is going to live in a box approximately this size. You can see down here where my hand is. This is actually just my voltage transmogrifier. It's being used to supply power. But the last step that hopefully I'll be able to get to within the next week is building the actual final box that this entire project lives in. It'll be about this big, sits on my desk. So all of the information you see being displayed here on the screen will actually just be in a box that sits on my desk. We're not going to have access to the microcontroller with a USB connector anymore. That's going to be buried inside of a box. And trying to make sure that the USB port is accessible on the edge of a box with all that design work is kind of a pain in the neck. What I would much rather do is have this thing fully wireless. So it's going to run on a battery, no USB cable or anything. So we need to add over-the-air firmware updates, and that's where we're at next. So I'm going to go ahead and put this into the configurator mode by holding the button down, and then we restart the ESP32. Now it's going to launch into the configurator mode. And you'll see we have a weird thing going on with the font. That's a whole different thing we'll deal with later. The next step, you can actually see down here in the bottom corner, there's this tiny little panel called OTA. What I want to do is I want to launch the ESP32 side of the over-the-air update by pressing this button. So it's actually a button. If I touch it, there. So I have this little special screen now that I can go ahead and run my OTAs. And of course I can use the bottom button to go back. And you'll see there's no information being displayed, so that's something else we'll have to figure out. If I just go ahead and restart it again, we are back, go through the splash screen, it connects to the network, back to the server, and we're up and running. So there's a lot going on, but luckily there's a lot of samples and example code that comes with the ESP32 that we can actually use to achieve this goal. So I don't really have to do a lot of work. First of all, let's go have a look at the base of the HardSense program. If you go to my GitHub repository, I am KiteCraft. I am KiteCraft everywhere, except in Twitter. I'm actually KiteCraft1 on Twitter. Oh well. Anyways, if you go to my GitHub repository, KiteCraft, you're going to see the HardSense program. We can go back, go into the repositories, and you will see HardSense. Now, the master branch is, of course, the most up-to-date, and you can go into the KiCad directory and get the schematics for how all of this stuff is actually wired up back here, or you can just ask me, and maybe I can help. I'll do a video about all of the wiring on this soon, because there is a real-time clock involved and a volume, a rotary encoder that's used as a volume control. So what we're working on today is, if we go to the branches, I'm working on branch number 19, add OTA 2. After the stream yesterday, at the end of yesterday's stream, I had gone as far as adding in this box and this acting as a button. But then I realized, okay, I don't know what to do after that, simply because the next step is to connect to the network, do a little bit of setup work, and then go into this OTA handle. And so there has to be this whole unique set of actions that has to happen. And this is the ESP32 is a dual core processor. Now, the way I've split up the functionality in HardSense is one core handles all of the serial work. This is all of the Wi-Fi work, the Bluetooth work, anything like that involves the communication. That's happening on core 1. On core 0, that's my display handler. That's where we actually, whoops, I'm bumping things, aren't I? There we go. Sorry about that. Core 0 is handling all of the display updates. Now, that's handling on core 0. If we actually go back to the base code, you'll see we have our little setup. We just simply set up this serial is just simply, you're doing your ESP32. That's just to help us with some debugging output or to see what's going on. But the first thing we do is we display this display handler. We initiate it with this new object called all queues. And this is where I came up with this major refactoring I did this morning. That was a big chore. But then we just set up this Bluetooth button. This BT button happens to be the blue button we're seeing on the display right here. We set up our timer information for the heartbeat, and then we do this. This is where we're actually creating a whole new task to run on our specific core, in this case core 0. And we're going to run this entire display handler function called TFT core proc, and that's going to be handling all of the interactions with the display. That's not just doing the graphical updates, that's also doing the touch screen. So when there's actually touches on the screen, they can be received. They're all handled in this little process. So let's go have a look at it, TFT core proc. It is down here. All it does is call display handler.run. And that's a very simple program too. But this is all handling on core 0. Now, you're mostly used to doing Arduino programs simply and straightforward. You have setup, and then you have loop. And it's easy, because both of those are running on the same core. And that's all of your code is just ever running on one core. But with a dual core, I've got this whole set of this whole application running on 0 core, and now loop comes along, and this is going to run on core 1. Now we have some multi-threading going on. This is actual. You have to start thinking in multi-threaded application program speak now. It's not just like your regular Arduino where everything's in a straight line. You now have two things going on. So to communicate between those two things, that's where the challenge happens. Now initially, if we go back and look at an earlier branch, let's say branch 17, this was not being handled very well. The communication between the two should be done with these cues. And what I was doing was fine. We go into software, ESP32. What I was doing was I was setting up these cue objects in the main ESP.INO file. This is the main program. I was also setting up these display mutexes, or these mutex objects that would act as the locks around the cue objects. And then down here at the bottom of the INO file are these two functions. Add item to the display queue and add item to the output queue. I wanted to make it easy to actually stick items onto the queue because reading from the queue is only going to be done in very specific spots. However, what this actually led to was some really funky code. So look at the display handler. We're passing it in the address of the queue, a copy of the mutex, the address of another queue, and a couple of function pointers. So I got a little crazy with these function pointers and pointers to the queues and pointers to this other one. And if we have a look at how the serial object was being instantiated, again, more queue objects. And then, so what we have happening here is the display manager really needs us to get information in so that it can do an update. So when it reboots, let's have a look at what's something that's going on actually. Okay, so this is the blue, and this is a really good screen to look at what's going on. You see the oscilloscope here that's clicking away. So this screen is only being updated by the clock. That is the only time any data on the screen changes. And that's what we see happening to the oscilloscope. The oscilloscope is actually connected to the chip select pin of the TFT. So every time the TFT is being talked to by the microcontroller, we can see that happen on the oscilloscope, on the little toy oscilloscope. Now, handling all of these cues, the serial object, has to just put items onto the queue, and then they're read in the other core by the display handler. And that's how we get data coming in from the Wi-Fi network. The serial handler, does its little parsing magic, and then just puts the information into the display queue, which is then picked up later on as soon as the display handler is available. Going back the other way is a little bit different because the only information that we're sending out has to basically go from the display handler through the serial handler and then out onto the Wi-Fi. So for example, when this screen loads, so when this home screen loads, what happens is the home screen is actually saying, it's sending a request back to the HardSense server saying, I want to see only this particular sensors. So that information is put into the output queue, which is then just passed on to the out. But what we don't have any way of doing is actually instantiating any actions. So when I push a button on here, this is simply just putting a message back onto its own display queue to change the screen. But what I need to do is I need to have an action where I touch the screen, and that causes the serial object or the serial manager to do something. And that was the trick. That was the hard part where things began failing. So what I've gone and done sort of solved all of that. We can now go ahead with a much easier time. What I did was I took all of those different queue objects and the mutexes and the functions, and I actually just stuck them into a class. So I still have the same header file for the queue item. I still have the same header file for the queue item, but now I actually just made a class, and I took those functions and those data types that I was declaring in the main INO file, and I put them into this header file, and I made a CPP file just to polish it off. So now this is making life a lot easier for me, because now here's what I can do. Back in our main INO file, this is all cleaned up with all of that garbage about what I was just showing you. That's all gone. None of that even exists in here anymore. All we have is this. We just create a queue object. This is the one queue object, and it's at this point it's being declared and defined. So it's taking up its nice bit of memory space, and it's right at the bottom of the stack, pretty much fairly early in the process, so we should be happy. But it's really not changing in size. It actually declares it to be a pretty specific size, and we should be good to go. Now, all that matters now is just the actual items that get put on. They end up on the top of the stack. But all we have to do now is we're just passing in the address of that object to the display handler and to the serial object. So no more messing around with, pointers, function pointers, and all of this stuff, and wondering where it's going to go and stuff. Now, there's just this one object, and we pass a pointer to it, to everything else. So all of the other child objects that are using this are all actually acting on pointers back to the main object that's being instantiated into memory, and that's where those locks come into play. They're actually only being used or accessed when those locks are available, so we're not running over each other. So the next step is this. We have to go back to our display handler, to our Bluetooth configurator. Where is it? Right here. Now we have an action here. When the Bluetooth configurator, let's pop into the Bluetooth configurator. Whoops, gotta hold the button down a bit longer. Okay, so there's an action here. So when I touch this panel, I want to engage the OTA capabilities. I want to engage the OTA update. So what I need to do is find out where I'm actually doing that. Let's see here. There is a handle touch function. Okay, so handle touch. If the OTA panel was touched, and that's what I've called this little panel, is the OTA panel. So we're now adding an item to the display queue to change the screen to the OTA screen. So I've started to create a new screen for that. Here we have the OTA screen header and just some basic text going up. That's why you see this happen. When I touch it, we pop over to a whole new screen. And then when I go back, it's just empty. So from here, I now need a way to send a command back to my serial object to say, okay, shut down the Bluetooth and engage the whole OTA function. So what I need to do is I'm actually going to have to create a whole new queue to do this. That's why I had to do that whole refactoring and clean up all our existing queues, because Now I get to add a new queue, and it's actually really easy to add the new queue. Watch this. This should be fairly simple. This should be fairly simple. I say that. We'll see what happens. So I need to go back to my queue item. Here we go. Not Doyle. That wasn't it. Where is it? Queue and queue. So first thing we need to do is we're going to add a new queue item, and we are going to call it command queue. I need a new mutex called command queue mux. And I need a new one of these, and oops, not way down there. What are you doing down there? Right there. Guess what this one's called? Add item to command queue. Okay, so now what I need to do is pop over to the item, and we actually need to just copy that. I'm going to rename it to this new function, command queue, right there. Okay, the mux that we need to use here is the command queue mux. Oh, paste that, and we need the command queue itself. Oh, you know what? This is going to crash, so what I really need to do is go back up here, copy this, take our command mux, so we need to initialize that to be unlocked, otherwise bad things will happen. And then we need to take this and we need to size it, but you know what, this thing's hardly ever going to get used, so I'm happy just to give it a size of 2. We could probably get away with just 1, but you know what, things work fast in this. And but you know what, while I'm here, I got to remember to come back, and I wanted to do some testing on this display size and see if we reduce this queue size down to like 6. Curious what will happen. I think it would be all right. I think I'm wasting a lot of space by creating these 2 queues so big, but I wasn't really sure. I needed to find out once I had a lot of data streaming what I can do there. So that's some tests that I'll be coming up with later. Okay, so we got a whole new queue in there. That was easy. Now what I need to do, you know what? Here's what I'm going to do. I'm going to go back to my global definitions file. I have some stuff at the top here. I have display commands, screen types. I'm going to create a new one of these called command types. Display commands, enum, HardSense commands. Okay, you know what? The first one I'm going to put in here, I am going to call it enable Bluetooth equals 0. Disable Bluetooth. Begin OTA. That's the one that I'm really wanting to know. Okay, so there, I've just created an enum for some new HardSense commands. Now what I want to do, this is going to work so brilliantly. I'm so glad I went through all the work of creating this whole new queue object. Oh, you know what? So the last build I did, we got to make sure, I almost forgot, I always like to keep notes of what's going on here. Let's go back up to the basic README file. So I've been keeping track of the build sizes. So the sketch uses 1.38. So that's the build size of the last successful build. That's the build that's running. Oh, son of a, that's running on here. Sorry, things are going to get a little more clumsy because I've sort of changed my layout again. So I'm trying to get the cameras giving me a good view. How's the view? Nobody's chatting. Hello, chatters. Let's go. Let's have a look at what's going on here. So that's still running. Okay, good. Okay, now I just wanted to clear this. Okay, I got my README. Okay, so I've just added a new display, HardSense commands enum. Now what do I want to do? Where is my Bluetooth configurator? Here's what I wanted to do. Here's what I was thinking with those commands. Okay, so here's what I'm going to do first. Not on this screen. This screen's already doing the right thing. It is actually calling a change screen command. So that's exactly what it should do. Perfect. Now, if we have a look at our serial object, now the serial object is going to be in this handle Bluetooth connection command. So what it does is it updates the Bluetooth display. So it's expecting to be on the Bluetooth configurator display. Right. Now, I wonder, what can I do? What can I do? What can I do? I'm just curious. What can I do here? Can I do this? I just need to see what's available to me. Disconnect. Anyways, I'm going to have to look into that. So what I want to do first of all is go to my OTA screen. Now, the OTA screen is this one. If I touch on the panel, we do that change screen command. Right? So the handle touch puts in the change screen command for the OTA screen. So now we're looking at the OTA screen, which is this screen. So we set up our theme. I need to pick a new theme for this screen. It's going to be more interesting. And then we just draw a string that says OTA, and you can see it does say OTA. Now, the first thing we actually want to do on this particular screen is, well, maybe not the first thing, somewhere down here. It'll be the last thing. Here's what I'm going to do. I'm going to go to my queue, all queues. I'm going to add an item to my command queue, and now I'm just going to use this as my template for the function call. There. So I don't want display commands. I want, what's the new enum that I just created? What's it called? HardSense commands. So HardSense commands, and I want, which command? I want begin OTA. And string, the payload actually can be empty. I don't need a payload on this. This actually is just going to act as a key, doesn't need a data payload of any type. So now what that does is that actually just going to stick an item, and then it goes through, builds everything, puts this item onto the queue, and then it just sits there waiting, just like every other screen does. It sits there waiting to be told that something on the screen needs to be updated. But now we actually have to handle this queue. We have to handle this command. So we got to go back to our serial object. Now, our serial object, where do we want to put handling this? I want to do it on the handle input or handle output. It's got to be in one, I think handle output's probably the best place to put the commands. I'm just thinking about the steps involved. Because at some point we need to action that. And it's actually going to be a bit of a blocker. Shoot. Is it? Yeah, I think it is. I think it's going to be a bit of a blocking action. Okay, this is the handle Bluetooth connection while waiting for BT connection. Where do I want to put? So somewhere around here, I got to put a little bit of an action. I got to stop, have a look at the new command thread or the new command queue, see if there's anything in the command queue, and if there is, do something with it. Basically, I got to figure out a good place to put it, and it's got to be in that thread somewhere. It's got to be in here. This handle Bluetooth connection. Because that's where all the work is done. That's where we're living on this. So we got to stick it in here. Where's a good place to put this? Why is this looking all red and nasty? Did I do something bad? What did I do wrong? Did I type something wrong somewhere? Did I make a mistake in my old cues object? Well, it just hasn't been, yeah, it'll be fine. So, yeah, so I'm still trying to figure out the best place to put this. Where is a good place to put this interaction? I think I'm going to put it in the handle input. Now, the thing is this actually gets called everywhere. So even if it's running on the Wi-Fi connection, so if we're running in our basic loop, we are doing this. We actually have some output queue work we can do here. And then HS serial handle input. That's the first thing we do. And it's that handle input is actually doing some neat work. So I'm gonna stick it in there. Nope, that might be a bad idea. Oh, the challenges of dual core programming. I'm trying to think of where I'm going to stick this, because there's a bit of work that has to be done, right? We're just taking this code and sticking it in there, but it's going to end up blocking, I believe. I have a thought. What if I put this code right and just stick it right in here? Okay. So the first thing I actually need to do, I just need to do a connect to the network. So I'm actually going to rename this. And I'm going to go down a slightly different path. So this is called handle Bluetooth connection. I'm going to call this handle configurator, because this is actually going to now do a few things. It's going to become the control function for both the Bluetooth and for the Arduino OTA for this stuff. Yeah, let's do that. So I'm actually going to have to rename this function, and I'm okay with that. Handle Bluetooth connection. Let's rename this to handle configurator. That's the word I've been using everywhere, is configurator. There. So now that should be called handle configurator. Oops, not over there, over here. Why didn't you rename it? Why didn't you get renamed? Handle Bluetooth connection. I don't like VS Code. It's really annoying me. Handle. I didn't, what? Handle configurator. Why aren't you renaming? Why are you doing this? What are you doing up there? Oh. You didn't do this to me before. How do I confirm it? Ah, VS Code. See, this is why I like. This is why I like Visual Micro from Visual Studio. It's just so much nicer to use and easier. It makes more sense. And unfortunately, it is a $26 or $27 a year license, and that's, you know, like I keep saying, that's $140 more than I can afford. But if you look down below, there is a PayPal me and a Patreon account. You can go ahead and PayPal me a donation to help me out. I'm trying to raise some money for, you know, buying better cameras. Maybe a microphone, doing the Visual Micro license, which would be awesome. You know, paying rent and buying food is always an option. So there's the bugs down below. Right now I'm looking at trying to figure out where I'm actually going to stick that Arduino OTA functionality. Where do I want to put this into my application? Let's see here. But I just did a rename, and I don't really trust VS Code's rename. So now I'm going to look to see if I screwed it up. Handle Bluetooth. See, it didn't rename it. Whatever. Anyways, I think I'm just going to better do a compile here just to make sure, because it takes so long to compile in VS Code. That's the other thing Visual Micro has above. It's so much faster. And no, I don't get paid by any of these companies. I'm not endorsed by anybody. Nothing like that. This is all my own opinion. I've made everything up. So just go along with whatever I'm saying. All right, so that's building. I just want to see, you know, if I did something stupid with that whole renaming. But what I wanted to do was just, yeah, handle. So first of all, I want to update the display. So I'm going to stick a new function in here called handle command queue. Now I want to just find this little bit of code that I've been using here for where is it? Nope. There. Where is that? There's somewhere else that's being used. There it is. What's going on here? Oh, it was display queue. That's where I wanted to steal it from. It was in here, the display handler. it had a much better example of the code that I wanted to use. Where is it? It is right there. Basically, I just want this whole little function. I'm just going to steal this whole little function, and I'm going to put it in that new little function that I was creating in the serial object, which I called, what did I just call it? Handle command queue. Did I put that in here yet? Yeah. Where did I stick it? Right there. Oh, that's why it's not working right. I got to do this bit to it. Now I want to change this to command queue. Well, it's not. Well, all queue, command queue is not empty. Not that one. I want the command queue mux. And then I want the command queue there. Now switch commands. Don't need this or this. And that is my new global, where is it? What did I call it? HardSense commands. Okay, now there was a, I had something here called OTA. What did I call it? Let's go back to my serial object. Something I called it OTA. Nope, I guess I didn't. I need a void. Yeah, void handle OTA. Okay, so now this is going to be the function that actually does the OTA work from that example file. Paste that there. Okay, what do we got going on here? HardSense commands. Oh, nah, that doesn't go there. That goes there. And the command I wanted was, I do believe, begin OTA. So case begin OTA. Handle. No, I don't know what's exactly going to happen here. I believe that's going to block. I believe, yeah, this is, of course, this is going to block, but is it going to block in the right, yeah. It's not going to block in the right spot, I tell you, that's not a good thing. Let's see here. Yeah, okay, well, you know what, let's stick it. I want to stick it both here and here. Yeah. So it's going to come in, check. If it's not empty, it just exits. So yeah, it'll slow those loops down just a touch, but not a big deal. These are pretty powerful CPUs. So if it's not empty, it comes in here, grabs itself an item. It locks the queue, grabs an item, unlocks the queue, has a look at what's what. Oh yeah, I got a yield in there. I better have a yield in there because yield will be bad. Okay, and then it's just going to pop over here. All right. So what should happen when I build this and upload it to the microcontroller? When I am on this screen, this is the configurator screen. When I touch this, it's going to load up this screen, and then we're going to see some text come out down here that says hello from this. But something broke, so let's go have a look at what broke. What did I do wrong? Oh. Semicolons. Okay, so clear this. Is this auto scrolling? No. Push the button. Now wait. And we'll wait till it loads. Now let's go, while that's taking its time, let's go have a look over here. We'll reboot this. Keep an eye on the oscilloscope and we'll see how the screen is getting updated on this particular screen. So there's a clock on this screen, right there, underneath my finger, which is why you see the continuous, we'll always see that same ticket right there. It's always in the same spot. It's always in the same spot as it was on the configurator screen too, because that's the tick that we're always seeing the clock get updated on quite accurately. And then of course there's the other ones being done around it. So the code is still uploading. Oh, look at that, just pinned my CPU. Wow, look at that, eh? Oh, so this is a compiling stage for the application, or for HardSense. Wow, just pinned my CPU. What a nasty piece of work. Still compiling, so slow. Visual Micro would have been done by now. It's just so much faster. There we go. Push the button. Now, like I said, what we're expecting to happen is if all of this new queue that I just added, rather simply, I must add, if this all worked, when I touch the screen on that one little on the OTA box on my configurator screen, I should see that new text get displayed in the terminal down here. So let's go ahead and connect the terminal. Okay, are we on auto scroll mode? Yeah. So I'm going to clear this. Now we're going to reboot into Bluetooth mode. So we're in Bluetooth mode. Now, when I touch this, we should see that little bit of text get written to the terminal. Hello from Handle OTA. I am just that good, aren't I? Look at that, there it is. Hello from Handle OTA. Now, check this out. Oh, I just figured out my way around it. Now, when we're on this screen and we go back, you'll notice all the text is empty. All the fields, all the information is missing. Right? So let me reboot this. When we first go into the Bluetooth configurator mode, you'll see there's all the information there. The clock is working correctly. The SSID and passwords are all there, right? And if we look at the oscilloscope, like I said, the screen is only being updated, it's only being refreshed by the clock data. None of the other information gets updated. So when we pop over to here, here's what's actually happening. Our Bluetooth configurator screen, this is the screen that's actually that we're looking at. Remember I said it's only updating with the clock. That's what's going on here. It updates the screen on the interval. If that interval is our last update time, or is the last update frequency, we go ahead and we update the time. That's why we see that the oscilloscope regular frequency. But that's all that happens here. Now, the very first time that screen is loaded, so the microcontroller boots up. When the microcontroller boots up, it goes through these steps, right? Boom, 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 boom. It does all of that, and then it gets to here. Is the Bluetooth button pressed? That's the button I'm pressing here. It jumps into adding an item to the display queue to launch our Bluetooth configurator screen. It pauses for 20 seconds, or 20 milliseconds. The only reason why we do this is that this is very early in our setup, so we're not trying to be impressive with our speed. But we want our display handler enough time to actually get this key and to actually draw the screen. If we just jump straight into handle configurator, we're now basically erasing these two threads. So let's give our display a bit of a head start. Just an opportunity to be able to draw all of that data. So then we go into the handle configurator. Remember the function I just renamed. So handle configurator updates our display. That's the very first thing it does. Now, this is why we want that slight 20 millisecond delay, why it's helpful to have. So we just put in a change screen command, and now we're actually calling this function update Bluetooth display with all of this information. We're putting all of these update value commands directly into the queue, so that what's now happening is that's where all of this text comes from. You see all the text here, star side, the stars, the ARRI, the 4121, all of that, that's all coming from here. Our update Bluetooth display. So if we go back to our Bluetooth, or our handle configurator, that only happens when we first launch into the configurator. We then go ahead and we do some other work. We set up our Bluetooth and whatnot, and then we get into here and we're handling our Bluetooth. We never go back and update any of that other. Actually, after we update the display here, we just set up some function pointers, do a little bit of work, make sure we're ready to go. But we never actually update that screen again, not until something else instigates a screen update. So what we're going to do, when we go here, the Bluetooth configurator just simply says do a change screen command, handle touch. It causes the display manager to change the screen, which happens. Now, as you know, all of the buttons, all of the panels have a built-in back button. So if I go back, our OTA screen, right, handle touch, if the hidden home screen is touched, we just simply call the change screen again to the Bluetooth configurator screen. However, we haven't given any command to reload the data back onto the screen. So here's what a neat way that we're going to do that now. Boy, it took me a long time to explain what I could have just typed out in 38 seconds. So what are we at? What we want to do here is add item to the Bluetooth configurator, and at the same time, all queues. Okay, so actually, first of all, let's add the key to the global definitions. So I don't need disable Bluetooth, actually. Let's go with refresh Bluetooth display. Okay. Now we go back into our serial object, into that command handler that we just wrote, handle command Q. I'm just going to paste this down here for now. Okay, we can take that back. Okay, so we want to handle the command what command do we want to handle? Refresh Bluetooth display by doing this. Update Bluetooth display. Okay, now we go back to our little OTA screen, the touch command. We stick that in there. Maybe we should delay for about 20 milliseconds just to give it a clue. Again, we're not in any hurry to set any speed records on the configurator screen. And now we're going to add all queues, add item to the command queue, HardSense commands, refresh display, and the payload can be empty. So now we're going to go ahead and compile this code. And what we're going to see, so now when we click on that, we go there. But when we go back, there's no data. I mean, the clock is updating, yes, because that's actually called on its own little interval. But there's been no refresh command for any of this other information. It's all empty. So this new change that we just did is going to cause a refresh of that data. This is going to be cool. This is going to work like a charm. Okay, let's go ahead and do the compile and upload. Clear that. Auto scroll. This is going to work like a charm. Watch this. This is cool. Let's go to the game screen and see what's going on here. So you'll notice the net panel is actually listing like a rather large download speed. That is true. This camera, both of these cameras that you see here, there's this one, and there's this one. These are actually both web cameras, IP cameras. So they're streaming over the network to my desktop computer. That's why we're seeing such a large download speed. Whoa, that's the back button I just touched. It is a sensitive touchscreen. It's beautiful. Look at that. Look at how responsive it is. Okay, we're still compiling code. Oh, yeah. Come on now. Still compiling code. Still, oh, there we go. Connecting, push the button. Okay, there we go. So now that Bluetooth configurator screen will refresh when we go back to it. This is going to work like a charm. This is going to be brutally awesome. Check this out. Watch this. Let's go to our Bluetooth configurator screen. Okay, so yeah, let's go ahead and touch it. So this goes to the OTA screen. Now let's go back. It didn't refresh. Wait. Why not? Why didn't it do that? Let's just have a look at what's going on. Is it still typing this out somewhere? No. Okay, good. Now, so why didn't it do that? Let's go back to the serial object. Okay, so it is still printing this out somewhere. OTA, yeah. HardSense commands, refresh, update Bluetooth display. I'm just going to put a serial in here just to see what we're actually getting in here. I'm going to get refreshed. I wonder, maybe I'm doing it too fast. Could be too fast. It's probably too fast. Yeah, it's probably too fast. I'm just going to slow that down just for the hell of it, just to see what's going on. I need this one. Let's put a bigger delay in there. And then let's upload the code. That takes forever to upload. Oh my God, take forever. So my goal was really to get onto some KiCad work and start working on some circuit boards for this project. If we have a look at the PCB board, come on now, there it is. You know, I've been wanting to finish this work off. I got a little more work. I may have been trying to be too stingy and scrungy and, you know, too finicky, and I'm making everything too tight, so I'm just going to back off and give everything some room. There's no reason to try and be this tight with everything. Is this finished yet? No, still going. Let's have a look at actually what this looks like in 3D. Come on now. It opened up over there. There we go. So this is the circuit board. Oh, are we ready for uploading? Yes. Oh, man, I'm going to cause some damage yet. Okay, so we wanted that to go to the configurator screen once it's finished loading. Okay, yeah. Okay, so let's reboot it into the configurator. Good. Now, back over to the desktop. I'm going to clear this, make sure auto scrolling is on. Oops. Which one is it? There. Now I'm going to go ahead and connect it, connect the serial monitor. I'm going to restart this into Bluetooth mode. Okay. Now, I should see some text. When I open up the OTA screen, nothing's going to happen. Begin OTA. Let's go back to our serial object. So begin OTA. So we'll see this text come up when I push that button. And then when we go exit from it, I should see this text come up. All right, let's see what's going to happen here. So let's push the button. Okay, so it did type out the right text, hello handle. So now when I go back, we should see it say going to get refreshed. Going to get refreshed. But it didn't refresh. Why didn't it refresh? That really should have refreshed. It's not refreshing the data. Why wouldn't that have refreshed it? I let it sleep long enough, didn't I? So when we initially call Bluetooth, it only sleeps for 20. And then it calls the configurator, which is the first thing the configurator function does is call update. See? Update. And that works. I'm going to do something interesting here. Let's see here. I'm just going to see what's going on here. If I go to the Bluetooth, okay, so if I go back to my OTA screen, I'm going to take this out of here, and I'm actually going to stick it into the Bluetooth configurator screen. And okay, so this could be an interesting new way to use this command function, this command queue. So I'm going to let the screen draw itself. Once it's fully drawn, it's then going to actually ask the serial object to send in a refresh command for the data. So now, even when we come back from this screen, when the screen redraws itself, it's going to dump that into the queue. And so this should work. This should work well. It should work this time. And the timing is even better. The timing is much better. Because what if I do this? Hang on. How much time am I spending in that loop? That's the question I never asked. It doesn't get called to way down here. So maybe I'm just not giving it enough time. Actually, I think that's the ticket, isn't it? Because look at it, there's data there. If I go back, and then here, it is working. Yeah. It is working. Good. Why didn't I think it was working? Why didn't it work that time? The hell? It was working. You saw it work. Worked there. Maybe I'm just but you know what? I'm going to try this anyways. I'm going to try this change anyways because this is an interesting change. I can always go back. So the Bluetooth configurator is going to call itself. The OTA screen doesn't have to call it. And the serial object doesn't have to call it either. Let's try this. I'm curious what's going to happen. This should be interesting. This should be really interesting. So you can see the oscilloscope is quite busy because of the screen is a busy screen. Lots going on there. Anyways, I was going to show you, while this is compiling, taking its time. So this is the circuit board that I want to build for HardSense, but I've decided, because this is going to be a home build jobby, I'm going to give it just a little bit more room around everything. I don't need to make it quite so tight. So I was hoping to get into some of this work today. I was just actually going to move everything over a bit, just give me some more space to run these traces through everything. Because this is pretty narrow, and I don't have to get so greedy with these traces. I can actually take, a trace like this that goes through and just run it down here the long way. Trying to avoid having to split these pads with any traces would be a good idea. So, and this is what the finished board will look like, except of course I think the ESP will be up on female headers and not connected directly to the board. Is this thing going yet? Yeah. Oh, I think I missed it. Yeah, I missed it. See, it says error. I didn't push the button. See, Visual Micro is so much better at, remembering to push the button for you. You have to hold the button almost every time with VS Code. With Visual Micro, you don't. That's all I'm saying. So, yeah, I wanted to move this line over. Whoa, nope, that's not what I was trying to do. What's my grid here? Yeah, good. Come on, there we go. Move it. Yeah, so we got to make some more room in there for all of that. I don't want to miss it this time. But that's what it's going to be, and I was hoping to get this made this weekend even, but we'll see. We will see. Hey, see, look at it connected this time by itself. I didn't even have to push the button this time. How annoying. Okay, so we'll let that boot up. I'm just going to hold the button down so we go straight into Bluetooth mode. Okay. Need to connect over here with our outputs just so I know what's going on. We'll pop into here. Turn on this. So it worked. It totally worked. You know how I know it worked? Because it got data. Cool. So I'm going to reboot this thing. We'll restart it. So it's calling a refresh on itself. How brilliant is that? So if I go into here, there it is. If I go back, oh. Now it's always going to be there. I never have to, it's calling a refresh on itself. Oh, that is brilliant. And it's fast. So does that mean, if I go back to here, this is my, I don't have to do this delay anymore. I don't even think I have to do this delay anymore. So this is for the splash screen. Nah, I think I have to have that one there. Okay, so let's go back to the serial object and clean up those stray commands I had in there. Handle command Q. So we know this is working. Brilliant. Okay, so that's brilliantly working. That's working brilliantly. I mean, that really is working. That's perfect. Now, we're ready to take the next step. We're going to take this code and see if we can stuff it in there and make it work. Alright, so what I need to do is, first of all, I need to connect to the network. Where's my handle network connection? Handle Wi-Fi connection. So yeah, we'll call that first, and the handle OTA, handle Wi-Fi connection. So that'll just connect us to the Wi-Fi network. Okay, so that'll get us on the network. Now we need to take this code and I'm just going to copy this, stick it in here, see what's looking at, see what we're looking at. There. Okay, I'm going to leave all that stuff in there for now. What's going on here? I need a header file, I'm guessing this one. Let's go up to here, we'll just add that header file in. Where's my handle OTA? There, yeah, that cleaned up that. Now, what about this here? So I don't know if this is a blocking loop or not. It must be. Okay, so here's what I'm going to try. I just want to know what's going on. Starting the handle funk. What the heck? The Arduino UI Arduino OTA handler. Okay. What the hell? Excuse my language. There. Okay, everything's lined up. Everything wasn't lining up. Okay. The OTA handler has left the building. Okay, so I don't know how long that blocks for, but let's find out if this actually works. So what I want to do now is compile this. Okay, so while that's compiling, let's just have a look at what's going to happen here. So it's just going to print out some debug information if we need it to. Okay. Yeah. Okay. Some weird stuff going on there. On end, ending, on progress. Now that's the interesting bit. This is where I'm actually going to put a feedback loop to the display. This will be awesome. Yeah, this is going to be awesome. So that's not going to block. That isn't going to block. Oh, if that doesn't block, oh, that's brilliant. Oh, we're going to have some good times now. Oh, please don't block. That'll be perfect. Okay, so the code is uploading. I'm going to go to the board config. Nope. I want to go to my port. So we got 5, 6, and 7 as ports. Okay, so that uploaded. That's fine. Now let's go ahead and start the serial monitor. It's connected. Okay, good. Let's pop into the Bluetooth configurator. It's not auto-scrolling. Okay, so yeah. Now, when I push the OTA button, that's going to jump down here. It's going to do all of this. And then it's going to get here. And then we're going to see what happens. Okay. So you see how it didn't block? That's interesting. I like that. Now I suspect... No. Shows up here. Hang on. Why does it show up like that, though? It shouldn't be showing up like that. It should be showing up as HardSense. Wait for... yeah, connecting to Wi-Fi star sign. Set host name. Yeah. So why did it show up as this? That's not right. Should be showing up as that. And why doesn't it show up in here? Let me see if it shows. Is there an option in here? No. This is another failing of VS Code? Why won't it give me that option in here? Oh, VS Code is horrible. I'm just going to have to do a quick search on that to see what's going on. That didn't help. I can just set port to be an IP address in Arduino JSON. Really? I can just change that to be my port, huh? To be the IP address. I don't know what my IP address is. But it should. Well, I shouldn't have to do that. You know what? I wonder. I'm very annoyed about that. VS Code. And why didn't it show up with the right address or with the right name? Okay, so that's interesting. I'm just looking at my router just to see what's going on here. Why it didn't show up with the right information. I wonder if it actually responds to a ping. Ping. Yeah, it does. So that's pinging HardSenseESP. I was hoping I'd be able to ping it by name. What's the reverse lookup here? Ping-H? What was the actual source address to use? Ping-S? Ping-A, that's what it was. Yeah, HardSenseESP. So ping HardSenseESP. Why would it work that way? You suck. Okay. Now, if this works, anyways, the code says that it should be, where are we here? The, handle OTA. We should actually see some on start. We should see some text being printed out if this actually works. So I'm just going to go ahead and see if this works. This should say Arduino port should say, oh well. I'm going to save that. Okay, fine. Let's go see what happens. I don't know what's going to happen. Let's go find out what happens. This might not work. Oh, it disconnected from the serial too. Alright, I'm going to have to do something slightly different then as a test. Here's what I want to do. I'm going to go back to the OTA screen. Okay, so let this finish. Where's my OTA screen? So case A, update data. So case A, I'm going to just create a little function here that's just going to be void update data. This is just a random little thing we're going to do here just to see what's happening. Watch this. Oh, wait. Sending invitation. Did it work? But there's the good thing. The compiling of the additional code only increased it by about 5% more. So perfect. I can definitely fit all the OTA stuff in here and still have lots of room to build more screens. I just don't know if that actually worked. And there's really no way to tell until I do this. Here's what I need to do. On the OTA screen, I'm actually going to add these as well. Where is it? There we go. This one. This is a good one to use. I'm just going to take this. And everywhere we do a print line, I'm actually going to just dump that in here. Plus a start updating. Now, did something just break? An arrow card will upload it in the sketch. Yeah, I'm sure. That's okay. I'm not too worried about that. Okay, so yeah, we're just going to put out some text and do the same thing. Why is this giving me an issue? Add item to display queue, update value, start updating. On end, update complete. And this one's going to be a different one. I'm going to give this one a B. What's happening here, eh? There's an interesting thing going on here. Progress divided by... Okay. Do I have enough brackets there? One more. String val equals a, no, B. B. File plus equal to string that. Progress. I'm just going to give us some text here. Okay, so what I'm going to do is back over here on the OTA screen. So I've got update data A, update data A, update data B, update data A, update, we're going to give this one B, update data A, sub value, B, sub value. Okay, where's my text printer? I'm just going to take this, so for update data, I gotta add some string, so hang on, I need something here. What do I need? Update screen. Update, I didn't do those right. I need Bluetooth, update password string. Yeah, I just need to add a string to those. String, data A, string, data B, data A, data B, sub value, yeah, oops. Okay. Now I need to take my sprite, create, yeah, I am going to just paste that here, and here I'm actually going to, what's my local chords? I'm just doing this for temporary bits just to kind of hold on to what's going on. So plus 65, plus 85, sure. So this should actually just update whatever text to that screen, so we should be able to see what's going on. Yeah. Nope. That's going to be bad. I need this to be data B, and I need this to be data A. Okay, good. Let's go, let's just give this a reboot. Go into Bluetooth configurator mode. Compile this. See if this works. This should, well, who knows if this will work. It didn't work last time. It got stuck here. You know what? While it's waiting, I'm just actually going to do a quick test. Let's just reboot this into the configurator. So the Wi-Fi should not be running there. So ping should not work. Good, ping is failing. Now if I turn this on, now we're into OTA mode, now we're running. Okay, good. No, that really is doing the right thing. So that's good. Now, let's see here. Let's see if this actually, if this does work. Why are you giving me a weird ass? So we should see some data get, oh, didn't like that. Why don't you like my old cues object? Why are you complaining about that? Like, seriously. You're right. No? Hang on. What am I doing wrong? All cues. Am I spelling the stupid thing wrong? Why is it complaining? Oh. Because I'm inside this damn thing. That's right. Do I have to qualify it? No. See? It's gonna give me the same damn problem. So how do I actually get access to that object from this inside this little bit? This is a new bit. I don't deal with weird shit like this. This isn't C. Huh. Well, that sucks. I don't have access to those cue objects from inside there. What do I do? Well, that really bites. I was expecting to be able to use that as my feedback mechanism. Well, anyways, let's take that out then. We'll come back and deal with that later. I'm going to do something else instead. Here's what I want to try and do. In my OTA screen, where we do that. So on the OTA screen, on the Bluetooth configurator screen, let's do it here instead. Serial.println. This is code added by OTA update. Now, what I'm going to do now is I'm actually going to open up this project in regular Arduino IDE. Now over here, I'm going to go ahead and restart my HardSense. Okay, if we go look at tools, now if we go look at tools here, tools, port, why does that show up? That shouldn't show up. that should not be there. I'm going to go ahead and unplug this. There we go. So, yeah, port 6 is gone. It should only be that port, but I don't like that. That should not be it. I'm going to go ahead and touch on that. It should be HardSense. It should say HardSense. Well, let's just see if this one works. I'm going to go ahead and try and do an upload from here. We'll know this works if, after I do all of this, I can go ahead and connect the serial monitor again, and we should see that new text that I just added. So if this actually comes out, then we know the OTA update works, but I'm not thrilled with the way it's working yet. Oh, something broke. Nope, it's still compiling. Still compiling. It shouldn't be called that. Oh, I have a problem. What is it complaining about? Bluetooth configurator screen. Error before all queues. On line 32. Oh yeah, shoot, I forgot to put the damn there. Okay, well, let's just do all that again. So I saved that, and we'll do the whole build process again. Okay, while it's doing that, I'm gonna go grab a drink. I know I got a mouse button there. So it's still building. I hope that volume is okay. It's not too loud, is it? Still building, still taking its time, compiling. Okay. Now let's see, does it connect over the network? And does it do an OTA update, or does it error out? Come on now. Come on now, you can do it. Please. Holy cow, come on now. Come on. Wow, is this ever slow? It hasn't even finished compiling yet. There we go. Okay, so sending invitation. Let's see, does it work? No. Doesn't seem to be getting picked up. Let's see if it's actually still up and running. Yeah, still running. Oh, maybe I'll forget. Maybe I missed something. No, this is just a straight code. I didn't do anything different with it. Oh, except for that. Arduino OTA set hostname. Oh, see, that's interesting. That's why I wasn't getting the right name showing up. So let's put that in here. in my serial object, in my OTA, handle OTA. Yeah, let's do this. HardSense settings dot Wi-Fi DID. So I'm going to have to upload this manually. So I want to go into my Bluetooth configurator screen. I'm going to comment this out so it doesn't get uploaded. Change my port. Let's plug this in. Okay, change my port. Port 6. Make sure that got saved, yeah. And we'll do the manual upload here. Clear that, auto scroll. Okay, I think we're getting closer, but we're not there yet. I don't know why. Why isn't it actually resolving to that name? Am I not spelling it right? I don't know. Okay, so now I've got the it should say HardSenseESP now, but why wasn't it working? Okay, we've got the HardSense here. Now let's see. We'll reboot this into Wi-Fi, into the configurator. Open up the OTA star side. Why does it say star side? It's supposed to say star sign? Okay, prints OTA X and Y. Oh shoot, that's what I did wrong. In these, I should have had these the same X, but I have to change the Y. Shoot, 45. 45. So I wanted this to be 24 and 44. So that'll work. Now let's go have a look. Tools, port, no. I'm just going to restart Arduino, see if that matters. Shouldn't. Okay, so there's no port on there. So it did matter. Let's just connect the serial output and see what's going on. Okay, Bluetooth. Connecting to Wi-Fi, so connected. Starting the OTA handler. The OTA handler has left the building. Tools. Port. Do I have to restart it again? Come on now. Tools. There's no network port. Okay, what am I missing here? Oh! Where's the first instance of this? Right there. Excuse me. Let's try that. Let's try setting it there before we do all of that stuff. That's all I can think of. That's all I can think of. I'm starting to get hungry. I'm starting to think about curry. Oh yeah, yeah, definitely thinking about a nice curry. Curry. Anyways, let's just get this. Interesting. So interesting. We're almost there. I know I'm almost there. I'm almost there with the OTA capabilities. Just about there. Just about there. I'm almost there. It's gonna work. It's gonna be cool having it, that's for sure. Gonna have to do some research into that object though. I don't quite like the way it's working here. Okay, we're rebooting. There we go. Now, port. No. Okay, so that's restarted. Alright, let's go into the configurator. We'll push the button. Tools, port, nope, let's restart it, I guess. Yeah. I was really hoping this was going to work the first time. Guess not. Tools, port, it's not showing up. It is not showing up. What's my connect to Wi-Fi look like compared to what they're doing? That's right. Oh, yeah. Might take more work than I thought. But it is connected to the Wi-Fi. I mean, that did work. It is there. It's all successful. See? It lives. Does it have the right ID? Yeah, it's working. It wouldn't be there if it wasn't. And we even got some feedback, didn't we? Star side. Oh, I know where that's coming from. I know where that's coming from. Okay, so I do have more oddities than I have to deal with. So that star side is coming from this line, because it's the A command. Yeah. Alright, good. Well, let's do that then. So let's change, so A is already taken here. So let's put this to a B and a C. Go away. That's because that A is already taken, so I want to switch those next commands to whatever I use as a B and a C. This is connect to HardSense server. I'm not going to need that. I wonder if that's the problem. It shouldn't be. It shouldn't be the problem. Oh, whoops. Pardon me, excuse me. Do I have to keep that in a loop? Maybe that's the problem. Yeah, maybe that's the problem. Huh, okay, so that's interesting. I'm going to have to do some interesting bits to explore here now. Well, I'm going to head out now. It is definitely lunchtime, or dinner time. So I got some interesting work to come up. That was fun. Almost there with the OTA capabilities, but I think I have another idea of what I got to do. So the whole queue object works, but I think what I need to do now is I need to actually break out of the whole Bluetooth. I think that's actually causing a collision because it's doing this whole input-output. Oh yeah. So I'm still running my own input-output commands while this OTA object is trying to do its thing. So my commands are overriding it, so I know what's going on there. This is going to be a little bit fun, but at least we know what's happening. Anyway, so thanks for watching the stream, guys, girls, people. Check below for my PayPal me and Patreon. You know, toss me a few bucks, I'll get better at this. Need a better lighting. Visual Micro would help a lot. That's a nice licensed software that I need to buy a license for. It's $26, $27. And so I will catch you all later. Hopefully we'll get onto the circuit board maybe tomorrow. Anyways, thanks for everything. This has been coding for ESP32, trying to stuff over-the-air firmware updates into my HardSense project. We're almost there. definitely almost there. Have a look over here. Boy, that screen is so reactive. As I say that, it stopped working. Beautiful. Okay, well, thanks again for watching, y'all. Take care. Bye-bye.
Shut up and sit down.